in the above circle, AB equals 4, BC equals 6, AC equals 5, and AD equals 6. So what is the length of DE? Now looking at the circle we have here, AB, this is AB here, from here to here is AB, so we're told the length is 4. BC here, we're told the length is 6. Then AC, from here to here, we're told the length is 5, and also AD, the length is 6. Now we are now told to find the length of DE. Now initially, when you look at a question like this, you might get puzzled. That is, you begin to wonder, how do you interpret the question? Because you feel you have not been given information, of which it is wrong. In fact, you have been given more than enough information to solve the problem. Now, to explain this, I'm going to lay credence to an information that I'm going to be using to solve this. But before I lay credence to that information, let me explain it. So let me call that 1. Now the information I want to lay credence to in solving this is that angles that share the same arc, they are equal. Okay, let me write that down. Angles that share the same arc are equal. Now looking at this, it might not really make sense to you, but let me draw a diagram. Let me draw a circle, and then you see the way the whole thing is being derived. So let's say you have a circle. So you have something like this. Now maybe this is your circle here. So what I'm saying here is, assuming you have, if this is the arc we are considering, the arc from here to here. So let's say you have an angle in which let's say this arc here, let's assume it subtends this angle here. So let's call this angle, A, that corresponds to this arc here. And then assuming for this same arc you have another angle that is subtended by the arc. Now what we are saying is, as far as these angles, like is this angle here, as far as they share the same arc, because as you can see here, this angle has this arc, and then this new angle here, they share the same arc. So what we are saying is their angle will also be A. So if this is A, this must also be A. Similarly, if you have another one, say probably you have something like this and then something like this, for the mere fact that they share the same arc, then their angle here must be the same. So if this is A, this must be A, and this must be A. Yeah. Alright, now that we know that, let's now come back here to the question that we have. Now before I begin to attempt to do anything, the thing is this: there are different clues when you begin to solve geometry problems like this. Now when you look at this, the angle that you have here, so let me call this angle X, and then the angle that you have here. Now what you observe is that this angle and this angle, they are equal. Why are they equal? Because opposite angles are equal. Opposite angles, they are equal. Whenever you have angles that are facing themselves, they are always equal. So if this angle is X, then definitely the angle here is going to be X. Now for the next one, now what you would observe is that considering this angle here, this arc here, let's call this arc BD. So let me shade this arc to make it thicker, so that I would see what's going on here. Now looking at this arc here, the arc BD, you would observe that you see this angle here. Look at the angle here, this one here, and this angle BED. You can see it here. So let's use something different so we don't confuse things here. So this is BCD and then angle BED. So you see the angle here. So the angle here is this, and then the angle that is subtended by this one here, the angle here is this. So according to what we have here, since angle BCD shares the arc BD with angle BED, then this angle and this angle, they have to be equal. So if this angle here, if we're going to call this angle, let's call this angle Y, then definitely this angle too must be Y. And then lastly, if you consider the other side of the triangle, that is when you consider this side here, this arc here. Now what you'd observe is, if you consider this angle CBE, see angle CBE here, you can see angle CBE shares this arc with angle, I have to use something different there. Okay, shares this arc with angle CDE. You can see, so this angle here shares this arc with this angle here, so definitely this angle and this angle, they have to be equal. So if you're going to call this angle Z, then definitely this angle here has to be Z. So now we know how this whole thing looks like. So what I'm going to do is, because the whole place looks a little ruffled up, I'm going to bring this triangle, I'm going to bring this one out. So when I bring this triangle out, so what I have here is, you have this, and then you have this. So this is what we have. So we have this to be A, this is my A here, you have D, and then you have E. So this is what we have. We have our ADE, and then we said the angle here, we're going to be calling this angle, we'll call this X, so we'll call this Y, and then we'll call this Z. Also, considering this triangle, I'm going to draw this triangle, I'm going to bring it out. So just for clarity's sake, so we have this, and then we have this. So what we have here, we said here is going to be B, here will be C, and here will be A. So we're going to call this angle here, we'll call this Y, we'll call this angle, we'll call this Z, and then we'll call this angle, we'll call this X. So now notice, the angle here is X, the angle here is X, the angle here is Y, the angle here is Y, while the angle here is Z, and the angle here is Z. Let me now come back to the question. Though what the question says here is, the question says that AB is 4. That is, from A to B is 4. So this side here is 4. BC is 6. So BC is 6. So this is that from here to here is 6. And then AC is 5. So AC is 5. And then also we are told that AD is 6. So AD, this is AD here, we're told that AD is 6. Now how then do I find the length of DE? Now someone who is smart would have noticed that these two triangles, they are similar triangles, but then it might not become very visible until I do some little adjustments here. So what I'm going to do now is, when you look at this triangle, I don't want to confuse you here, but I just want to try and do a little demonstration here. This triangle, the triangle I drew here, could also be drawn like this. So I want to do a lateral inversion. So this is my A. I want to turn it upside down. I want to turn this triangle upside down, or should I say left to right. So what you'd have when you turn that upside down, you have something like this, and something like this. So this is, if this is A, this is going to be A. So if this is C, this is going to be my C, and if this is B, this will also be my B. It's still the same triangle. So since this is my B and this is my A, now if this is my B, this is my B, the angle here is Z, so the angle here has to be Z. If this is my A, the angle here is X, so this has to be X. And if this is my C, this is my C, the angle here is Y, so the angle here has to be Y. So to make this triangle to be the same thing with this, I have to put the sides here. So it says AC is 5. That is AC. So from here to here is 5. So we are told here is 5. BC is 6. So BC is 6. So where is BC? So BC is 6 here. And then AB is 4. AB is 4. That's from here to here is 4. Now, when we look at our triangle that we have here, the angle we have here is, we're told that AD is so if this is X, this is X. You can see here, If this is x, this is x. If this is z, this is z. If this is y, this is y. Now, anytime you have triangles such that they have the same angles, that is all the angles in a triangle, whenever they are the same, you would say that such triangles, they are similar triangles. Now, such angles are similar triangles. Now, the beauty of similar triangles is that for similar triangles, the ratio of any side of the triangle are equal. I'm going to write that down. So the ratio of any side or any corresponding side of the triangles are equal. So the ratio of any side of the triangles are equal. Now, when you look at this, now you have xz. You can see that this side here corresponds to this side here. So I'm going to call this 6. So we're going to use the same color here because this is x, this is z, this is x, this is z. So if here is 6 and here is 4, so they correspond to each other because they have the same angle. Now, what I'm told to find is, it says what is the length of DE. The length of DE, so that is from here to here. Since I do not know the length of DE, that is from here to here, I'm going to call that length, I'm going to call that A. So A here, so I don't want to confuse things, let me just use a different color here. So this is A here. So this DEA here corresponds to BC here. Corresponds to BC. So we're going to use the color 6 here. Now, why does it correspond? Because the angle here is Z and the angle here is Y, while the angle here is Z and the angle here is Y. So they correspond to each other. So I'm going to lay credence to what I said here. It says the ratio of any side of similar triangles are equal. So what it says is, now for this triangle here, the ratio of 4 all over 6, that is 4 divided by 6, the ratio of this side must equal 4 all over 6. 4 all over 6 must equal the ratio of the corresponding side, because they are similar triangles, must equal 6 all over A. So you can see what I did here. So the ratio is 4 all over 6, and then here is going to be 6 all over A. You have to do it the way it is. It must correspond to each other. Now, based on this, so I want to find A. So to find A, I'm going to cross multiply. So what you have here is going to be 4A equals 6 times 6, which is 36. So to find A, you divide both sides by 4. So this goes off. So you have your A to be equal to 36 divided by 4. That's going to give you 9. So our A is 9. So the length of DE is 9. So that gives us the solution here to be 9. Please, if you do have questions, please drop your questions in the comment box below. The whole thing looks a little messed up, but if you try and watch when you watch this video the first time, you might get a little confused, but I advise you can watch it over like 2 or 3 times to get the whole picture. Yeah, thanks for watching.